Welcome all, and thank you for joining today's AWRI webinar. My name is Matt Holdstock, and I'm one of the AWRI-nologists, and I'll be your webinar host today. In the spirit of reconciliation, the AWRI acknowledges the traditional custodians of the country throughout Australia and their connections to land, sea, and community. We pay our respect to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander people today. In this session, we will be looking at the seasonal climate outlook for the summer of 21 to 22. But before we jump in and make a start, a couple of quick reminders to anyone who is new to the AWRI webinar program. If you would like to provide a comment or ask a question, please click on the Q&A button on the Zoom toolbar, type in your question and click send to send it through. We'll be holding the Q&A session at the end of the presentation, but feel free to send in your questions at any stage throughout the webinar. A reminder also that this session is being recorded and you will be emailed a link to view the recording on the AWRI's YouTube channel later today. So for anyone who's just joined, welcome to today's webinar. The topic is seasonal climate outlook for the summer of 21 to 22. And it's a great pleasure to welcome Dr. Paul Bierman from the Bureau of Meteorology. Paul is a meteorologist with the Bureau of Meteorology in South Australia. Paul has worked in a number of roles with the Bureau since 2010, including on severe weather and fire weather forecasting and warning, aviation forecasting, and agriculture decision support. Paul, if you're ready to make a start, I'll hand over to you.
Thanks very much, Matt, and good morning to everyone. And thanks very much for joining us today. I'll just get started with sharing my screen for my presentation. Hopefully that's sharing there, is it, Matt?
Yes.
Okay, so in the presentation today, I'll first run through a quick look at the year to date for rainfall and temperatures around the country, and then more recent conditions through October. I'll then look at the climate drivers that will affect Australia's weather and climate over the next few months, and then look at the rainfall and temperature outlooks for this summer. So to start off with, looking at the year-to-date rainfall from January to October 2021 around the country, we can see that's been sort of a mixture of some areas wetter than average and many areas that have also been drier. And you can see here the blue areas where it has been wetter than average through many parts of Western Australia and many parts of New South Wales and Victoria and also Tasmania, but also plenty of areas, particularly so here in South Australia, where we have had below average rainfall so far this year. Overall, across the country, it has been Australia's wettest January to October period since 2017. But for southwest of Western Australia, it's been the wettest period since 1964. Temperatures, I've got the maximum temperature here on the left and minimums on the right for January to October this year. Obviously, yellow and orange areas where it's been warmer and the bluer areas where it has been colder than average. Generally been a warm year so far across the north of the country, particularly sort of through Northern Territory and Queensland, where we have had very much above average both maximum and minimum temperatures. Also seen warmer than average days through parts of South Australia and Tasmania. And for nights, we've seen above average minimum temperatures through parts of Western Australia, Victoria and Tasmania as well, but cooler than average nights through inland parts of South Australia, Northwest Victoria and New South Wales. More recently, across the southern cool season, so from April to October, we've seen rainfall across the southern half of the country about 13% below average, averaged across the southern half of the country, but been drier than average across many parts, including much of South Australia, but near average rainfall has occurred near southern agricultural districts of South Australia. We have seen above average rainfall through parts of Victoria, New South Wales, Tasmania, and in particular southwest Western Australia, where they've had their wettest southern growing season since 2005, and rainfall there has been above average, about 12% above average. For the Murray-Darling Basin, rainfall there has been still 14% below average for 2021, but still around double the amount of rainfall recorded there than was recorded through all of 2019. southern growing season. More recently, in October, we've started to see more above average rainfall around the country in less sort of below average areas. Still has been a wetter than average month through large parts of Western Australia, particularly sort of near the coast. For the southwest of Western Australia, it has been the wettest October since 2011. For the state as a whole, rainfall has been 22% above average, but for the Southwest Land Division, had rainfall of 66% above average for October. Also quite wet in Tasmania. We've had the 10th wettest October on record for Tasmania, and the highest since 2016. Rainfall there was 69% above the average. For South Australia, most areas have been sort of near average for October. Likewise for much of New South Wales and Victoria, it's tending above average, sort of near the coast. Maximum and minimum temperatures for October was quite a hot month across the north of the country, seeing some very much above average maximum and minimum temperatures through parts of Queensland and Northern Territory, in many areas even highest on record. Elsewhere has generally been either near or cooler than average for southern areas, particularly southwest Western Australia. We've had cooler than average both maximum and minimum temperatures, and cooler than average conditions or nights through much of South Australia, Victoria and New South Wales, but quite warm nights throughout Tasmania in October. Onto the soil moisture then. So in the main map here, I've got the soil moisture analysis. For the top 1 metre of soil, blue areas are where the soil moisture is predicted to be above average, and the red areas drier than average. We have had sort of obviously a mixed bag here again. Moist soils where we've had above average rainfall through Western Australia and parts of New South Wales and Victoria, but generally for South Australia near to slightly below average soil moisture. Quite different to what we saw during October of 2020, quite wet sort of around the state this time last year, so notably dry for South Australia this year, but other areas, particularly Western Australia, soil moisture is much higher than at the same time last year. And pretty much the whole country is seeing much improved soil moisture compared to this time in 2019. Water storages, all the major water storages are higher this year compared to the same time last year, up to around 82% for the northern Murray-Darling Basin, 89% in the southern Murray-Darling Basin, and 65% in Tasmania. So we'll now move on to the climate drivers. So what I've got here is the sea surface temperature anomaly. So the difference from the average sea surface temperature. The main area of interest is this region out here in the equatorial central Pacific Ocean, where the Bureau monitors for development of La Nina conditions. So where we do have cooler than average waters out in the Pacific does indicate a La Nina may be forming and could produce wetter than average conditions through eastern parts of the country during summer. And out in the Indian Ocean, these two boxes here represent where we monitor for the Indian Ocean dipole, and the difference in the water temperature between these two areas is used to calculate the status of the Indian Ocean dipole. So first of all, onto the El Nino Southern Oscillation. So this is the sea temperature anomalies out in the Central Pacific. For most of 2021, all of 2021 so far, conditions have been in that neutral range, but during October, conditions have gotten close to that La Nina threshold of 0.8 degrees sort of below average, and the model does predict that we will reach that threshold during November, and we are likely to go into our La Nina. And the models also predict staying in that La Nina pattern right through until January before conditions most likely returning back to neutral early next year. So the Bureau's El Nino Southern Oscillation outlook has been set to La Nina alert, so predicting around a 70% chance of La Nina forming during the summer, about 3 times the normal outlook, the normal likelihood. And as well as the Bureau's model, all major international models also predict La Nina is likely to form in the coming month and stay in La Nina pattern until early next year. So just a reminder here what La Nina can mean for Australia, where we do have stronger trade winds across the Pacific Ocean. Those easterly winds drive upwelling cold water near South America, and the strong winds push that cold water into the central Pacific, but also push warmer than average waters into the area north of Australia. And that provides more moisture in the atmosphere for rainfall, and also the stronger circulation provides greater convection and increased chance of rain falling to the north of Australia. So this pattern generally drives increased rainfall, at least for northern and eastern parts of the country. It also decreases temperatures, maximum temperatures outside of the tropics. La Nina can also mean more tropical cyclones as a result of the warmer waters to the north of the country, and also increased chance of widespread flooding, particularly through Queensland, New South Wales, Victoria and Tasmania. Despite, on average, we do see cooler days around southern parts of the country, we do have longer duration heat waves are possible. Don't usually see the extreme heat that we more typically see with El Nino conditions, but they can be more humid and persist for longer. Crossing the Indian Ocean then, the Indian Ocean dipole has been near that negative threshold for much of the year, which usually drives wetter conditions throughout winter. But that index is now back in the neutral territory and is expected to remain neutral throughout summer, and doesn't usually impact Australia's rainfall too much during summer anyhow. Next, the next driver, which doesn't usually get as much attention as La Nina, is the southern annular mode. This refers to the north-south movement of the western wind south of the country and the cold months that bring rainfall to southern Australia. When it's positive during summer, those westerly winds are further south, so too that tropical ridge moves further south as well. That gives us generally more easterly winds across New South Wales and Victoria, and that draws in moisture from the Tasman Sea and the Coral Sea to further increase the likelihood of wetter conditions around southeast of Australia. The southern annular mode has been positive for about the last month and is expected to remain positive throughout the rest of the year. So that does reinforce the trend for increased likelihood of wetter than average conditions, at least through much of New South Wales, Victoria and eastern Tasmania, potentially also the southeast of South Australia. Positive southern annular mode typically occurs during La Nina conditions, so those two climate drivers often reinforce each other to produce above average rainfall. So to summarise the climate influences then, technically the El Nino Southern Oscillation is still neutral, but it's getting close to that La Nina threshold, and it is looking likely that La Nina will form by the end of the year and persist until early 2022. The Indian Ocean dipole is neutral, expected to remain neutral throughout the rest of the year, and the southern annular mode is positive and likely to stay positive for the rest of this year. Onto the temperature and rainfall outlooks then for the coming months and seasons. So here in each of the next few charts, I've got maximum temperatures on the left, minimums in the middle and rainfall on the right. For the temperature maps, blue areas, we're expecting most likely below median daytime temperatures or nighttime temperatures, and red areas are where temperatures are more likely to be above median. And for rainfall, blue areas indicate increased chance of above median rainfall, whereas orange and brown areas will indicate favouring below median rainfall. So for the majority of the country throughout November, we are expecting below median maximum temperatures, exceptions being far southeast of South Australia, coastal parts of Victoria and Tasmania. And for minimum temperatures, large areas favouring warmer than normal nights, exceptions being much of Western Australia, also northeast New South Wales and southern Queensland, where cooler nights are possible. In terms of rainfall, strong signal here for above median rainfall throughout South Australia and much of New South Wales, Victoria and Tasmania as well. I should point out that this forecast here was produced at the start of the month, and already almost halfway through the month now, we've already seen quite a few rainfall events around the country, with the the low moving through South Australia today and into Victoria and New South Wales tomorrow, we are likely to see some quite heavy rain in the coming few days, and so it is quite likely that this rainfall scenario will eventuate, with a lot of that rainfall falling in the space of time. However, as we move into December, however, conditions do change, notably for many areas. The signal for wetter conditions does ease back quite notably. In terms of maximum temperatures first, still looking at many areas expecting cooler days, favouring below median maximum temperatures for much of New South Wales and Victoria, and some parts of South Australia as well. However, warmer days become more likely still through much of Tasmania and Western Australia. For the nights, above median minimum temperatures through large parts of the country still, particularly so through Tasmania, Victoria and New South Wales and eastern parts of South Australia. And for rainfall, still expecting above median rainfall through much of Queensland and New South Wales and also Tasmania, but for West Australia favouring below median rainfall. Elsewhere, around a 50% chance of exceeding that median rainfall, so no strong signal to either wetter or dry conditions than normal, so near average rainfall most likely. Across the summer period from December to next February, for maximum temperatures, still favouring cooler than average days throughout eastern parts of New South Wales, and above average days through Tasmania, Western Australia, central and eastern parts of South Australia and western New South Wales and Victoria. For minimum temperatures, quite a strong signal there that nights throughout summer will be above average for most parts of the country. And for rainfall, favouring above median rainfall through Queensland, New South Wales, Victoria and Tasmania, and some parts of South Australia as well. However, for most grape growing regions in the south of the state, closer to a 50% chance, so no strong signal of those wetter conditions throughout southern parts of the state. And for Western Australia, slightly favouring near average or slightly below average rainfall in some areas. On to the next 3-month period then, from January to March, a similar pattern, still expecting the cooler days through parts of New South Wales and eastern Victoria, but warmer days through South Australia, Tasmania and Western Australia. Warmer nights expected for many areas once again, and the rainfall pattern still favouring that above median rainfall through the east of the country, driven by the Nino, still into early next year, but for other areas, near 50% chance of above median rainfall, so most likely near average. What I'll point out now is a new feature that's only recently become available in the Bureau's climate outlooks. So whereas the previous maps I've shown basically only show the likelihood of rainfall being above or below median, so basically categorising the prediction for the coming month or season as either into 2 bins, either wet or dry, and the likelihood of each. Now what we can do is break the likelihoods up into 5 different categories. So we can identify what's the chance of the coming month or the coming season being in that unusually dry or the unusual wet part of the records for each location, or the unusual cold or unusually hot. So it's all relative to the climate and the historical observations for each location. I'm broken down into a 5 kilometre by 5 kilometre grid across the country. So we can basically say what's the chance of the coming season being in the top 5th wettest years or the top 5th warmest years, based on your location. So first of all, what I've got here is the November to January outlook, and on the left map here shows the likelihood of the coming period, 3-month period, being unusually wet. So I guess by definition, there's usually a 20% chance of the rainfall being in any of those 5 categories, but when the chance is more than 20%, when we're getting up into that 40 or 50% chance, which we are seeing for much of South Australia, New South Wales and Victoria, we are saying is around twice as likely as any given year of being unusually wet. Like conversely, for the chance of unusually dry conditions, we can see here that the likelihood is sort of below that 20%, so around 10%, so half as likely as normal to be unusually dry. So what I've pulled out here an example of some locations around the country, but you can go onto the Bureau's Climate Outlook webpage and search for your town, or click on the map and get predictions for your locations. Here we've got bottom left here, Margaret River. You can see around an equal likelihood for the next 3-month period of being in any of these categories. But for other locations here, I've got Barossa and Coonawarra next to that, Mildura then, and Yarra Valley, Hunter Valley and Launceston. So each of those locations, strong signal for favouring rainfall being in that top fifth of wettest years. So for Coonawarra, for example, predicting an 80% chance of above median rainfall over the coming 3 months, but also predicting a 54% chance that rainfall will be sort of in that top 20% of years, wettest years. It's important to remember that it's all relative to that location. So 54% chance at Coonawarra and a 33% chance of being unusually wet at Hunter Valley doesn't necessarily mean Coonawarra will be wetter than Hunter Valley. It just sort of compares this coming season compared to what's normally expected at that location. We can do the same for temperatures as well. So I've got the maximum temperatures here. The chance of being unusually warm, we are seeing around a 30 to 40% chance for southeastern parts of South Australia, and around a 50 to 60% chance for Western Tasmania of being in that unusually warm 20% chance of years, whereas parts of New South Wales actually have around a 30 to 40% chance of being unusually cool in the coming season. And for minimum temperatures, many areas, particularly through South Australia, Victoria and Tasmania, have a high chance of being unusually warm for minimum temperatures over the coming 3 months, whereas no areas are very likely to see unusually cool conditions over the coming months. That map that I pointed out showing those very high chances through that November to January period, quite different to what we see through December to February. So it was largely driven by sort of rainfall predictions through November. By the time we get to the December to February period, the signal for unusually wet does decrease quite a lot. So we are still seeing large areas through Queensland, New South Wales, Victoria and Eastern Tasmania, where we are seeing around a 30 to 40% chance of conditions being unusually wet across the summer period. And the chance for South Australia does ease right back. So still favouring wetter conditions, and still an increased likelihood of being unusually wet, but not as strong a signal as we were seeing for November. And it's still a lower than normal chance of being unusually dry throughout summer. For temperatures, mostly just Western Australia, where we are seeing increased chances of being exceptionally warm, and only parts of New South Wales where we're seeing an increased chance of being unusually cold. And for nights, most areas of the country have an increased chance of seeing unusually warm minimum temperatures, but particularly so through the tropics, and no areas really showing a strong signal of being unusually cold for nights across summer. One more thing I should point out is this does look at the average conditions across the month or the season, so it doesn't necessarily mean any particular night might be unusually cold. So you might still get the exceptionally cold or hot day or night, but on average throughout the season, it's very unlikely that we'll have below average nights. Just to finish off with then, this is my final slide. This looks at the severe weather outlook for November to April. As a result of the increased rainfall likelihood in the east of the country, at least, widespread flooding does become more likely. Severe storms, to mention, is similar here, but I think with the increased moisture in the air, that generally does drive more storms. So I'd suggest some areas do have an increased chance of severe thunderstorms over the coming months. Bushfire risk is increased for some parts of Queensland and New South Wales, but for most areas it's either similar or decreased as a result of recent rainfall. Heat waves are more likely through summer, but they're not expected to be as extreme as we get in some years, and they're more likely to be more humid but longer lived. Tropical cyclones are more likely this year compared to other years, and drought is less likely. So I'll just finish off there with this summary page. But as I mentioned, El Nino is neutral at the moment, but La Nina is expected to form, and that is driving that wetter than average conditions expected throughout much of east of the country. Thank you. Back to you, Matt.
Thanks, Paul. There's a couple of questions have come through. The first one is, how predictable is hail? Are there tools for predicting hail?
Oh, sorry, I missed that. If you're talking to me, then.
Sorry, Paul. Yep, just a couple of questions have come through. The first one is, how predictable is hail? Are there tools for predicting hail, or does the Bureau have tools, I guess?
Hail is particularly sort of hard to predict with thunderstorms. It's very much a short-term thing. It's pretty hard to sort of look ahead at the next month or season and see, what's the chance of hail. It's really need to sort of analyze sort of the observations of even the day or the day before thunderstorms are occurring. That takes into account the instability of the atmosphere. You really need sort of warm, moist atmosphere down low and cold air above to drive that a strong uplift to be able to hold hailstones in the air for long enough for them to grow to those larger sizes. And you sort of need sort of dry and cold air in the upper atmosphere. So you really need to be able to diagnose the situation sort of in the short term and to predict where those thunderstorms with hail may be forming and where they may move to. It's not really something you can look ahead and predict weeks or months ahead.
Okay. There's another prediction question. What about wind? Are there any predictions for a windier or less in the coming months?
That is something that the Bureau is working on, possibly implementing as part of their seasonal outlooks in the future. But at this stage, it's not part of our service, and I'm not really aware of what may be coming sort of this season. Sorry.
It's okay. Might be one for the future. There's one other question. If we're leading into a La Nina pattern, does this reduce the chance of frost?
Yes. Typically, our La Nina pattern does increase rainfall, often brings with it more moisture throughout the atmosphere and more cloud, which usually does lead to warmer nights. So you get that sort of insulating factor from having that moisture in the air. So frost becomes less likely over the next couple of months, but you can't rule out the odd extremely cold night here and there. It does. Overall, warmer nights are more likely, but the odd extremely cold night can't be ruled out.
Okay, I don't think there's any more questions at this stage. So if there's no more questions come through, I'd just again like to thank you, Paul, for providing an important insight into the upcoming weather of the coming months. I'm sure everyone who's attended today got a lot out of the session. I'd also like to thank the audience for joining in and taking part, and always like to remind you that, as always, you will receive a link to view the recording of this presentation on the Adabari's YouTube channel. Just also like to acknowledge Wine Australia for providing funding and support for the Adabari webinar program through the Adabari Extension Project. The next Adabari webinar is on tomorrow, November the 12th, and it's titled Bouncing Back from a Hail Event. So if you would like to register for this session, please visit the Adabari website. Thank you again today, and I look forward to seeing you all at the next Adabari webinar. Thank you.